Welcome to my channel. Today we are going to discuss the difference between potential difference and electromotive force.
The difference between potential difference and EMF can be demonstrated like this. Consider two bottles filled with some water. One is at this level and the another bottle is filled little higher than the central line. What happens? One is at a higher level and another one is at lower level. These bottles, if I connect with some pipe, the water started flowing from this direction to this direction until both the bottles will attain the same level. Consider an electrical circuit, say contains some resistor R, and across this we have connected some battery. What will happen? We are connecting this battery, the end, if you call these terminals as A and B, the terminal A is at a higher potential and the terminal B is at a lower potential. Current has to flow from higher potential to lower potential. So if you compare these two concepts, here the difference in water level leads to flow water from higher level to lower level. If you modify this sentence related with this, the difference in potentiality of the terminals to flow charge from higher potential to lower potential. That is the one concept. So the difference between these two potentiality is known as potential difference. Now what will happen if the Coulomb charge started from traveling from positive terminal to the negative terminal? It started its journey from here, and what will happen here, once it reaches A, it needs some potentiality to travel from higher potential to lower potential. So this charge has to spend some energy taken by this cell. So suppose this is a battery of 10 volt and this is the resistance of 5 ohm. That is the Ohm's law states that V equals to IR. So it is nothing but I is equals to V by R, that is 10 by 5, that is 2 ampere of current flowing through this circuit. Now what will happen? The energy required to cross this resistance and to travel across these conducting wires, as these conducting wires also offer some resistance to this charge. So charge has to travel with some energy. That energy is taken by this cell. So suppose EMF is an electromotive force, even though it is called a type of force, but according to me, it is nothing but it is an energy supplied to the charge to travel across this circuit. So what will happen when the energy taken by this battery by the charge which is traveling across now this circuit is suppose 10 joule. Now what will happen once it cross this and cross all the and complete the traveling through whole circuit? Once it reaches the negative terminal of the battery, the Coulomb charge which has started its journey across this circuit has lost its almost its energy gained by the cell. Now what will happen? Now battery will give 10 joule of energy again to the Coulomb charge to again start its journey. So the difference between potential difference and the EMF are like this to flow. So we can distinguish PD and EMF like this. PD or voltage, you can say, or voltage makes electrons to flow. Okay, while EMF maintains the PD. In other words, you can say PD represented by the voltmeter reading in a closed circuit. If circuit is working, means key is closed, the circuit is closed or circuit is working, then only we can measure PD across any resistor or any terminals. While EMF represented by the voltmeter itself in an open circuit, means the circuit is not working, the switch is open, that means switch is open. In that case we consider EMF. So in short you can remember like this: when circuit is closed we measure PD with the help of voltmeter. When the circuit is open we measure EMF of the cell with the help of voltmeter. The formula given to calculate PD is V equals to I into R, while EMF is calculated by I into R plus R. R is a external resistance and small r is the internal resistance offered by this cell itself. That's it.